Welcome back to the Aussie Shed, ladies and gentlemen, for episode 4 of the 6x9 belt disc sander repairs and modifications. As you can see, work has been done. We're very lucky today to be joined by Michael J. Fox on camera. Michael, hold that camera still. That's the way. Okay folks, as you can see, the base has been painted and the new bracket affixed and also painted. The extra bearing has now been fitted to this side in this position to give support on the belt sanding platform on this side. It's all looking very good and I'm quite pleased with it so far. You can see the motor controller is now assembled, completely custom and cobbled together by none other than myself. I'll even light it up for you. There you go, we've got power. So, I won't turn the potentiometer on here yet, just because there's no motor attached. But, as you can see, she's all in there. And for this particular situation, what I've done is fitted a double power point to the outside of this box. Box being just a cheap eBay plastic enclosure, fitted with all the particular gear. That's the new magnetic switch. Safety switch, as I mentioned before. Give her a bang and she's done. Very safe indeed. And as I mentioned, it's magnetic. I'll just flick the power off over here. Excuse me, I've just got to get in front of the light to get to the switch. Flick him off. As you can see, I'll flick him back on. Nothing, because the magnetic switch has deactivated it. Very nice indeed. Just over here, I have a small junction box, which is where the output power is coming from the motor controller, and that's just waiting to be connected up to the treadmill motor when she's affixed. In just a moment, I will extrapolate on this here cobbled together motor controller, which is very successful. I've done many of these, never had any problems. They are rock solid. Anyhow, I'll just show you the adapter plate that I've made to fix up this misalignment on the base from where I fitted the treadmill motor. So this is the adapter plate that I've made to properly mount the treadmill motor this time. As you can see here, there was an alignment issue which I got over at the time by drilling a series of threaded holes on one side here and using this slot on the other side. It was alright, but it was a bit of a pain in the ass if you needed to adjust the belt tension. Sliding the motor was a bit of a pain in the bum because you needed to get to the bolts underneath. I had cup head bolts in there to try and alleviate the problem, but it just kind of sucks. So this is what I've done. It's just a bit of 6mm plate. There are two studs on that, there are 4 studs on that side, 4 studs on that side. The holes have just been drilled and the studs have been just plug welded in from the other side. So how this works, pull back a bit. Michael, hold the camera firm. Stop shaking. So the bottom studs just drop into the original slots for the original motor, which gives us a little bit of movement down here and properly aligns the new motor in this direction here. So what I plan to do is sit that roughly where I need it to be, put some nylock knots underneath and some washers and mount that like so. That gives me the new mounting position for the treadmill motor. Studs coming up, it's great. I can just throw nylock nuts and washers on the top, gives me a really easy adjustment. Job done, very nice indeed. I've also at this particular point in time finished this piece as well. Oh Jesus, I'll just get that off my car. This is the guard, the belt guard for the disc sander, which mounts on here like so. I've made a little bit of a modification to this. I've just put some 5mm thick, 50 by 5mm maybe, flat plate inside just to stiffen it up and mount it a bit better. You can see it bolts on through there. Because it's fairly light sheet metal, and the where it fixed on originally, it was, you know, it's pretty averagely done. It used to just flail around a bit. The biggest problem with it was it used to vibrate like a bastard at high speed, and it used to just drive you up the wall. I wedged a few bits and pieces in it to try and temporarily stop it, but it always used to just drive me nuts. So stiffen it up with a bit of plate. Drilled and threaded a couple of holes in here to bolt it all up nice and firm, and it's now sweet as. Very tight, won't move around again. Absolutely fan-bloody-tastic. Now over here at the bench, you can see I have the belt platform all pulled apart, ready to go. Just giving it a bit of a clean up. Just needs a little bit more work with a flat wheel in a few areas just to clean stuff up. Quite a daggy, irregular edge on this end. It's quite sharp as well. This end's not quite as irregular, but still quite sharp. I've been over the platform face as best as I can, just with some paper and some flat stones, etc., just to try and lever it up a bit. It was pretty good. Just that I had a bit of a look at it and give it a bit of a touch up, but it's not too bad. You can see this is the belt adjusting mechanism, or part of it. That's about to get a clean up and a coat of paint. I've recently replaced all the bearings in the idle roller on the front and the drive roller on the back, so they're still pretty good. So basically that's my job for tomorrow. Just get all these cleaned up, get a coat of paint on them, and she'll be looking good. I've also bought a graphite wear pad for it. I understand that the later models of these actually had a graphite wear pad on them. This one never came with one originally, and even in the spare parts list currently for this machine, which you can still actually buy all these years later, I've found, it still doesn't come with a listing with a graphite pad for it. So I found another 6-inch belt sander that's roughly the same size. I've just got to cut about an inch and a bit off the end of it, but the width is perfect. Nice adhesive graphite pad. So once she's all painted up, that'll be going on there just for a bit of that ooh so sweetness. And that's probably where I will be at after tomorrow. So I'll get back into that, and I'll see you again tomorrow with hopefully this painted. And what I plan on doing is laying out a motor controller on the bench, because I do have all the spare parts to make up another one, so that I can give you a clear view of everything that's packed into that control box on the side of the unit that I've done, so you can see it as plain as can be, and I'll explain it all component by component. Nothing to it, piece of piss, you're going to love it. Alright, I'll be back shortly. This is the underside of the base. You can see where the motor mount fits up, and you can see the original slots here for the original motor mount. As you can see, there's just a washer and a nylock nut. This allows me to have adjustment on both sides. This adjustment really is just to locate the new motor mount in the optimum position, but it also gives me scope for more adjustment later on if I need it. This is the new Treadmill motor mount. You can see it's also slotted, so honestly, that is the only adjustment I will probably need for belt tension. If at any point I need to, I can always loosen the nuts on the underside of the adapter plate, reposition it, and then readjust using the slots and the nuts on the top. All in all, I think it's a pretty flexible solution. This is a breakdown of the DC motor controllers that I put together to control the treadmill motors that are running most of the equipment in the Aussie shed. They're very simple design. There's lots of guys on YouTube have videos about these exact same motor controllers. So not hard to find, but this is my version. This is your main component. This is an SCR AC motor controller. It has a potentiometer mounted on the front. I'll just slide that cover off there. You can see it just has two wires that run to it that clip into the board there. Nothing much to this. It's basically just that fixed onto a big aluminium heatsink. If you choose to have this potentiometer mounted in a different position on your machine, if it doesn't work out right, I usually just either, if the wires aren't long enough, just snip it, solder in some wire and move the thing to wherever you want. In the belt disc sander conversion that I've done, I've actually trimmed down this heatsink as well, just to make it fit in the box. It's quite a big beefy heatsink. I've never noticed them getting even warm, so cutting them down's not a real problem. The other component that makes all this work is a bridge rectifier. This converts your AC signal to DC. You can see the part number on it there. Just bring that up. Focus, baby, come on. You can see it's AKBC5010. Okay, now they're really the two main components. That's really all there is to it. This is AC in, AC out, and you run the AC out line into your bridge rectifier, and then you run the outputs from your bridge rectifier into your DC motor. So let's have a look at how we do that. And in this application, like just about all the others, I generally run an LED light just to know that we've got power on, because if your potentiometer is turned off and the motor controller is live, you don't really realise unless you have something that tells you. This is just an AC mains powered LED light. You just drill a hole for them and put them in and wire them up, and away you go. Okay, so let's have a look at the wiring. So let's have a look at the connections on the SCR controller. You have in, out and COM. In is your mains active in, so either the red or the brown wire. COM is your neutral connection. Now this is your neutral in and out is your active out. So you've got active in, neutral in, active out, neutral out. So there will be two neutral wires going into the COM connection. One is the AC input and the other is the AC output on the neutral side. And then active in, active out. I'll get some wires in there so you can get a better idea of what I'm talking about. As you can see here, I have a power lead, and you can see coming out of there you've got your active, which is your brown, neutral, which is blue, earth, which is green. Now you can see I've got a wire connected onto there. I've got a red wire onto the brown, which is our active, and I'll have a black wire onto the blue, which is our neutral, and green with a yellow stripe, or yellow with a green stripe, depending on which side of it you're on, which is our earth. For the sake of this demonstration, I'm also wiring in a power on light. which is going to be the second wire that's connected on the active side. So there's two wires here. One of them is the active coming in from the mains, and the other is the wire that goes, as you can see here, goes to the active side of this light. So we'll just slip that into the in, which remember is your active in. Tighten it down. Now your active out is the next one across. That's in the center there, the connection that's labeled out. That is your output. So another red wire. Remember, that's your active, and we'll just put that one in there. And that's the output that will go to the AC connection on the bridge rectifier. Now for our COM wire, this is where all of your neutrals join together. So all the black wires, I've got three wires here. One is the neutral in from the power cord. One is the neutral out, which goes to the other side of the bridge rectifier. And the third black wire is just the neutral side of our switch. So if you don't have a, is the neutral side of our lamp. So if you don't have a lamp, you'll only have two. You'll have a neutral in, neutral out. But if you're wiring a lamp in here, you'll have three. So that's all our connections made. I'll just pan back so you can kind of see everything connected in. So as you can see here, this is our mains input. You can see the red wire from here traces through and goes into the in on the left there. It happens to be joined with another active wire which is going to this lamp. Out, which is the center connection, goes out to one of these connectors here, which will be going to the bridge rectifier. And on the neutral side, which is your COM, which is your common, you have a neutral connected to your neutral wire from your mains power in, which runs into the COM connection. There's also a neutral for your lamp, and then a neutral out, which is this guy here, which runs to the bridge rectifier. To make the connection to your bridge rectifier, the connection marked AC, I generally just put the active. Now bridge rectifiers run diagonally, and that's very important to remember. So your neutral AC terminal goes diagonally opposed to it in such a fashion. Okay, so remember you have AC, which is your output from the SCR. Diagonally opposed to it, you have the neutral output from the SCR, and that's your AC output. So at this stage you've got AC in, AC out, coming out through here into the bridge rectifier, and then what comes out of these two terminals will be DC. Now the two wires that you're going to connect onto your treadmill motor here, it doesn't matter which way they are connected. All that will do is reverse the polarity, which will reverse the rotation of your treadmill motor. So if when you connect it, it's spinning the wrong way, all you have to do is reverse these two connections and it will turn the other way. So I'll just make this connection here now. Pull this fella across a little bit. I'll just plug these guys in, no particular way. As I said, depending on the way that they're plugged in, it really just governs the rotation of the DC motor. At this point you can see the plus marked side, which is opposite the AC marking. I have the red output wire on too. Now the other thing I haven't talked about here is earth connections. You can see I've got an earth coming from our mains. Generally when I wire these in, I will drill a hole in the side of the SCR and attach an earth connection to it, and then loop back to the motor, which you can see on here. The motor has an earth wire as well. It has it has 3 wires coming out of the back of it, active, neutral and earth connections. And when I fit these to any machines, I generally tend to run a lot of earths. I will earth the motor controller, the body of the machine, the control box, anything that I possibly can run an earth wire to that's metallic, I will run an earth wire to. You can never have too many earth wires. Reason being, if something goes wrong, it's the path of least resistance for the power to go to ground. So if you're not running earth wires, if you have stuff that's not earthed and it becomes live and you touch it, you become the earth wire, which is how you get electrocuted. So remember, earth wires everywhere, starting from your mains power in, to here, to the motor, to everything. Remember, you can just loop this wherever you want, just cut it, join them together with proper connectors or solder them. Remember, you must have lots of earth connections, and I'll demonstrate all the earth connections that I have on the disc belt sanding machine in just a second. So basically that's all there is to it. So we've got power comes in, light just to let us know that we're on, potentiometer to govern motor speed, bridge rectifier to convert from AC output to DC output, wired into the treadmill motor. I'll just set this up so we can see what's going on. There we go. I'll just hit the power switch. The orange light should come on. Like so. We now have power. I'll just turn the potentiometer here, and as you'll see, just like that, we have power to the motor, which we can just turn up and down as we please. Just like that. And that's all there is to it. Very, very simple indeed. Once again, you really should have a switch in from your AC before you start going into anything. That's where your power switch is located, where these terminals are here. I currently don't have a spare power switch that I can wire in to show you, otherwise I would. But I'll show you on the belt disc sander. It has a switch in that position. That's the where I put the magnetic switches. But yeah, that's all you can see. But yeah, that's all there is to it. As you can see, it's very, very simple. 10,000 watt SCR motor controller, bridge rectifier, light if you need it. I highly recommend using a light just so that you know the thing's live. And you're good to go. In Australia, our DC motors are 180 volts. In the US, I think they're a little bit less. And from what I've seen on YouTube, guys are having to change out this potentiometer for a different value in the US when they do these conversions. But for here in Australia, if you're using we've got say 230 volts coming out of the wall, the treadmill motors here are 180 volt DC, and it's a fairly good match. Obviously, when this is running flat stick, your output is still going to be 220, 230 volts. So you're actually going to be overdriving the DC motor a bit, but I honestly never run them full speed. There's just really no need to do it. I generally gear them in such a fashion that they're running at probably 3/4 speed when they're going flat out, which is probably about, you know, feeding it probably about 180 volts at that point anyway. Yeah, it's just a very simple way to do it. I've been doing them like this for quite a long time. As you've seen in a lot of my other videos, every machine in the shed runs a treadmill motor. These same motor controllers run them, whether it's the big drill press conversion, the belt disc sander, the bandsaw, everything's running these. They are just really, really simple. The SCR motor controllers cost about, I think they're about $10 US. The bridge rectifiers, they're like less than $1. They're like 50 cents. The lights are only a couple of bucks. It really is just cheap as chips to put these motor controllers together. I'll turn this off and then I'll go and give you a demonstration on the belt disc sander, which everything is all properly wired in, and you know, like as I was saying about the earths, all the earths have been run everywhere, and it's all just neat and tidy, and you can see what it looks like all in position. And this is what the whole thing looks like when it's all said and done. You can see what we have here is our power running in, which is this behind there. You can see that red flex cable. That's your power coming in. In this situation, it's looped into a power point, runs back out into the switch, which is here. Hit the switch, power then runs back into the motor controller, exactly the same motor controller that we were just looking at on the bench. As you can see, I've cut the heatsink down to allow it to mount in this box. I've only trimmed a little bit off it, it's all good. Another thing I didn't mention, the bridge rectifier, I've actually mounted it onto the heatsink as well because they do get a little bit hot. So I've just put some heatsink compound on the back of it. They have a hole through the center, so I've just run a self-tapper, I think, through it, or a bolt, not sure which now, and just fixed it to the heatsink. It just makes it all nice and neat. So this is wired up in exactly the same way as I just demonstrated on the bench. The output from the bridge rectifier then runs back through into this other flex that then runs through the machine and over to the motor. Now you can see all the earth wires. You can see, as I mentioned, there's a hole drilled in the side of the motor control, the AC motor controller box, which has an earth connected to it. And there's another earth connected in the back there, which earths the cabinet. And then there's another earth wire that runs through with the flex back up to the motor, which goes to the motor and also earths the motor base out. So yeah, that's the whole unit there. As I mentioned, I've put a power point on here as well. When the machine's plugged in, that power point becomes active. It's not switched with the emergency stop here. I could have switched it quite easily that way by running the power input to the switch first and then to the power point. I've actually done it the other way, power point first and then to the switch and then out to the motor controller, because the problem with having the switch control the safety switch control the power point is if I'm just using the power point, and what I did with the previous stand was I used to use it to mount bench grinders and things on as well. Because it's on wheels, I can push it outside. And when you're doing those sort of dirty, horrible jobs, it's really great to have something that you can wheel outside and do it. So once this is plugged in, and you can see I've got a nice long lead on it, I can then mount a bench grinder on it and then just plug that in here. And whatever tool I plug in will have its own safety switch anyway. So I might plug this sucker in, and then just give you a bit of a demo of the same thing. Most of this unit's back together now. She's starting to look kind of complete. All the drawers are in, table's on. This is all mounted up properly. Motor's in. She's all hooked up, and this is all done. So once again, this is just a demo of the whole thing enclosed in the box, just so you can see what we've got going on here. So hit the power, bump switch, hit the power, turn the potentiometer, and you can hear the motor kick up, which is over here running happily. Very nice indeed. And that is all there is to it. Just a bit more to do at this stage, a few more things to paint up. I have to repair and paint the original table that goes onto the disc sander side, and I still have to paint the main belt sander platform, which I'll be doing shortly. The weather here is a bit crap at the moment, and as soon as it gets warm enough and dry enough to paint, I'll get those on and it should be looking good then. I don't have a replacement disc for it yet, as in the accident the disc was destroyed beyond being able to be repaired, so I'm yet to track down another disc for it, but I can still fit a pulley on there and get the belt sander back in action, which is the main thing I use most of the time anyway. A couple of things to paint, should be looking really sweet. Fantastic news, ladies and gentlemen. The weather has cleared and I've been able to repair and paint the disc sander table and also finish off rebuilding and painting the belt platform. So let's take a look. The belt platform came up a treat. Everything is now nice and painted. The belt tensioning and tracking mechanism has been painted and tidied up. The whole platform has been deburred. I've been over all the casting with a die grinder and a power file and a few things just to clean up some of the original dodgy looking casting, which helps with being able to properly keep the machine clean. There's nothing worse than rough, horrible cast areas that you can't clean stuff out of because they're so that are so grainy and coarse. She's looking pretty good. I'll just drop that belt platform back down. That's how she looks from the back side. You can see I've got this bearing fitted onto here to support the table on this side now. It just helps with those bolts not having to take all the tension when you loosen them off to tilt the platform up. They're no longer having to physically hold all the weight of the platform. They now ride on the bearing on this side and the two bearings that you saw previously on the other side. Time for a quick walk around. There's our control box with all the units that we saw earlier. You can see up under the table adjusting platform mechanism thingamajig. This is the original disc sander platform. It was quite damaged in the accident. It's all been straightened up and repaired and painted, and a bit of cold bluing. This rod here that runs through into the machine that actually holds the bracket that supports the table, it was cold blued, and also these two shafts that hold the front idler roller were also cold blued. I did a bit of a quick video on that just recently, so if you're interested in cold bluing in the home workshop, take a bit of a look at that and you might find it a little bit interesting. Everything else has just been painted. Yeah, not too bad, pretty happy with it. It was a bit of a blessing in disguise actually breaking it. It's allowed me to do things that I previously probably wouldn't have done. Ditching the original base that it sat on was quite a godsend really. Now I've got all this storage and a much nicer machine to go with it. So all I've got to do now, throw the graphite wear pad on, put a belt on it, see how she runs. Graphite wear pad is down. Bit of a tip for young players. Urethane roller. Very good for bedding in adhesives. Particularly something large like this that you can't really kind of bang down with your hands effectively. A urethane roller is an invaluable tool. Alright, that's looking pretty good. Let's get a belt on this sucker. And there it is, ladies and gentlemen, in all its glory. The fully rebuilt and restored 6x9 belt disc sander, minus the disc. Quick demo. I've roughly tracked the belt. I'll run it for a bit and then probably readjust the tracking, but it's not going too bad. This, I'll turn it up a bit and give it a bit of a whirl. I'll probably have to turn the audio down a bit though. Let's crank him up. That's not too bad, eh? But watch this. Now that'll remove some material. Even faster. So you can imagine at that kind of belt speed, it really just peels the material off. Stainless steel, mild steel, whatever. It's just really great. Cleaning up miters, Linisher flat plates, really, really handy. And even more versatile when the disc goes back on it. It's just a really great handy machine. It's pretty hard to get a 6-inch wide belt without paying an absolute fortune for a machine. It just makes it incredibly versatile. So there it is. Thanks for sticking with me through the journey of the rebuild of the 6x9 belt disc sander. Very happy to have you here. Once I get a new sanding disc sorted for it, I'll make a quick video and give you another demo. Alright, and as always, thanks for watching. It's a thumbs up from the Aussie Shed. Hang on, hang on, hang on, hang on, hang on. Don't go anywhere yet. There's something we have to do together. Yes, folks, the time has come. We have to do what should have been done a long time ago. It's time to test out the JB Weld to set the critics straight once and for all. How will she hold up? Oh no! Not very good at all. Lucky we fixed it properly. Okay, you can go now. Or maybe not. Oh, Jesus Christ, Bella. I get scared by loud noises. I'm recording this. This is all on camera, you know. Yes. I'm in the middle of making a YouTube video. And I'm going to leave this in. Thank you. It's the middle of the night here, and as you can see, my son's girlfriend likes to scare the shit out of me.